Hi everybody, welcome to part 4 of our project 2-band regen radio build. As you can see in front of you, I have the same box and I put the parts on top of it. We'll point them out to you. That's only a short video to point out to you how you can position your parts. Let's have a look if we get something to point. I should have done that at first, but then it matters. Yeah, I'm very busy this morning, so I had to do quite a bit. Anyway, there you have your coil, of course, reception coil. There is your switch. That's the main part I want to talk about. This is a two-way switch, and actually there are 4 on them. There are 2 on this side and 2 on the other side. And why do I do that? Because I have to switch those 2 points to the tuning capacitor, alright? But the other point is, I have to make also with this, I have to do some band spread in the capacitors in between, because of the 100 picofarads capacitance. You're not going to use that in the band, so we have to shorten that, but we're coming back to that later. So anyway, that's what I want to say is I want to position that switch around here somewhere, yeah. And then you have your antenna valve, and here's your VR, what is connected to this one. So what I would do is to put the VR further back, have an extension on the axle, so the axle extends outside, so then we have the VR exactly on the place where we want it. That is, it's always better to have it all close together, and of course then you have your antenna connection on the back here, alright? Then of course we have to take the car into account. We have to make some turns on the bottom part of this. I have to fix this coil, preferably, because otherwise you have all these some funny noises like echoes or everything, so we have to fix that thoroughly. And then we have our tuning capacitor here, but it's then connected to our switch, yeah. Oops. Then we have a reception valve, yeah, with our low frequency amplifier, with our output transformer. Actually, you can put that output transformer underneath in this case, because he's so small. You can see that he's so small that he will fit underneath, so we can put him underneath. It saves you a lot of room up top. So anyway, I'll leave that here. Then we have our valve here, and then we have our volume here. And we can extend that also. We can put that further back and extend the axle if it needs be. And we have our tickler here. Now this VR is about 1K. This one I will get oneself about 5K or something like that. And that won't be enough, you know, because we probably you need about 400 or 500K, but I will get them in series with other resistors, and then try to pick the point up where the tickler works best. Alright, so we don't have to turn the whole VR. Then we have a bit of spread in that VR as well, so that makes it a bit more pleasant to tune the tickler to get them right. Okay, then we have our volume control. And then you can see our famous transformer and our speakers. You see, you can put everything on that frame, and that is okay. Alright. Now I have to think about it. I want to say something more. Yeah, I wanted to say something more. Anyway, those axle extenders. Here there are 2 little screws in there and there, and they fit on the potentiometers or the VRs, and then you can put another piece of axle in there, and that will extend that a little bit. Okay, you can get them somewhere I know where we get them here in Belgium or in the Netherlands. So that actually you can see it's quite simple and quite easy. I use them quite a lot, you know, because it's a great solution if you want to do something like that. Anyway, oh yeah, I remember now. This transformer here, you need a voltage here from 250 volts. I'm going to tell you something very funny. Anyway, if they want to adjust the frequency or the tuning of this radio, it could be helpful to have something there, a potentiometer or something like that, that you can regulate also the voltage. Because, believe it or not, also the voltage has influence on your feedback, on the clarity of the signal. So it is quite a fiddle, to be honest. I have that with this little one here. You have that on the this one little here. You see I use that little valve there as well. Yeah, and there's also 80 meters. Yeah, I made that as well. It is a very nice little radio, you know, because yeah, it is a bit difficult because this frame is so small. I can't put any transformer on there. And anyway, you can you see the filament 6.3 and then the high voltage where you put on there. I used the power supply I have on my bench. I used for that. But anyway, it's a very nice little radio and it works very well actually. But again, I discovered because of that power supply that I had an influence from the voltage as well. Just that's why I'm telling you that, and you can see what you can do with a few little things. So you have here for a headphone, and you have to insulate that from chassis because the high voltage is on there. So there you go, and put that aside again. Anyway guys, you can see approximately how the layout is, and you can do quite a lot. And my advice to you is to try to put those VRs as close as possible where they are needed. There is room enough, so there's no reason why you shouldn't put a little bracket here and put that VR behind that and rivet it down on the bottom and have a little hole here and with the axle sticking out. And then you have no problems with capacitances or whatever. So influencing one another. If you have long wires underneath, there's bound to have some influence. So my advice to you is to get so short as possible, get as close as possible together, and then yeah, this radio will work. And you have this, let's see, 1, 2, 3, 4, 5 knobs, and then we have a few beautiful knobs. I have some in my stock. I bought them way back, and I think I'm going to use them. I don't know what I'm going to do with this tuning capacitor, if I make a little scale on there or whatever. That would be nice. Anyway, I will see. And well, you need, on this tuning capacitor, you need band spread. You know why? It's 180 degrees. You want to have your band spread. If you want to tune your band, say for instance is the 30 meter band is 7 megahertz and 7.2 megahertz, and you want to have the tuning from left to right. Just on one side left is 7.0 and the other side is 7.2 or a little bit higher. You never get that completely straight. That you have it's always a bit over, but it's not in the 40 meters not bad because you have a broadcast band on the top. So you can listen to that as well. So from the 80 meter band it's just the same. You try to have 3.5 on the left hand side and 3.8 on the right hand side. It probably won't get exactly there, but even then, if you only have a bit of loss on both sides, at least you have a big part of the tuning capacitor that you can tune properly. And if you have a tuning capacitor and full capacitance at 100 picofarad, that will tune, say, into 4 picofarads. Can you imagine what this is going to do? this is going, you can't even 20 mil past it already. So it's very well, I'll work it out for you, what you have to do with this tuning capacitor, what kind of capacitors you need for that. Anyway, there are MP0 capacitors, so they are not reacting to temperature or anything like that. So they're quite steady in their frequency or capacitance. That's very important. And then as far as I know, you can get them up to 120 picofarads. So you can, if you make a series of them, then you divide actually capacitance, and you just can. The smallest capacitance, that's the working range you will have. The smallest working capacitance. You can work that out on a calculator. You can see that it will be, if you have, say, for instance, 30 picofarads in series with 100 picofarads, and you will find that it will be less than 30 picofarads. If you get my drift. So then you can choose, you know your minimum capacitance, you know your maximum capacitance, then you can choose your series capacitor exactly right to tune 180 degrees. That is, in theory, is that so, but there's only a little but on there. We have capacitance in that coil, and we have the wire capacitance as well. So it is, if you say straight what I'm saying just now, 30 picofarads, 100 picofarads, you probably have to adjust that a little bit because of the capacitance what is present in this coil and the capacitance that is present in your wiring. So it is trial and error. So that you know. But then we can take a good look at the position I put it all in. That should be approximately how this layout should be. Okay? That's all I have to say on this video. The next video will be about drilling. Put this valves in place and get my tuning this transformer winded. I didn't do that yet. Anyway, it doesn't matter. Then you need your VRs. The only would say this VR could be 100Ks, 400Ks, I don't know, it's depending on the schematic. And then you put a smaller VR in there, and then you try to find two resistors that you put in series with that, one on this side, one on the other side. You see where I'm going with this, that you have where you put that capacitor, this is VR, where your tickler works best. So you have a very small range, and then you have a very small resistor, VR resistor, to tune that properly. That's how I do it always. And then you're not fiddling around in a little corner, and there's too much, it's too less. You know what I mean? And then you can do that properly. You have a bit of spread in there as well, so that's very pleasant if you have that. Anyway, the next thing we're going to do now is just get this all together. You notice that I'm going to put this on the bottom. Then we get to the transformer, and I want to say something about that as well. This radio, I said that it needs about 250 volts to work properly. Yeah, it goes on less voltage, but then again, it's going to have influence on several things. You can use two transformers. You can use, if you have the transformer what is used on the continent, the 235, 6.3 volts. You could use that one, and you have a 6 volts, 120 volts, 6.3 volts. Then you could use that, the two 6.3 volts, you put them together and you feed the filaments from those two valves with it. Alright? Then you can use the other transformer as the 235. You have that for high voltage. And it will work properly because there's no problem at all. But there again, if you are good enough, I don't know the exact word for this. If you are handy enough, if you have to experienced enough to understand how a transformer works, and so on and so on, and you have the tools, and you have a machine. I have a machine to wind this kind of transformer. Then you can wind them yourself. You can do it by hand though, and there has some explanation on my Blogspot channel. I have also a Blogspot channel, and you can find an explanation there of how you make a transformer. If you are in the position to get the metal for it and the former for it, so what belongs to it. This is about a 25 watts transformer. It's not more than that. It is approximately 25 watts. That's far what is needed. So you don't need a bigger transformer. That 25 watts is more than enough. You can buy those little transformers, I think, from the factory. What I'm saying, so if you have, say, 1-2 amps, 3 amperes, then you are already in business for the high voltage. This it takes about 10 milliamps, or roughly 10 milliamps. Yeah, it will be 30 milliamps, something like that, because this is a pentode. 30 milliamperes you need for this about. And a transformer puts this away quite easily. It gets a bit warmer. This takes a lot of power to burn out the transformer. You actually have complete short to do that. Anyway guys, long story, very short. I'm going to finish this video. This video is just intended to give you some information how you put it together, and I will see you on the next part. Alright?